This section is on spontaneous processes. These are processes that occur on their own without any outside assistance. When you release a brick from your hand, it will fall, it will not go up. When you let a nail sit in the rain, it will eventually rust. Spontaneous processes occur only in one direction, and the reverse reaction is always non-spontaneous. We're going to go into a little more detail. Experimental conditions are very important. So what do we have? First, we say, please don't confuse spontaneity with speed. Thermodynamics, this chapter, tells you the direction, but not the extent of the reaction. That's going to be equilibrium. Kinetics is speed. This is going to be our direction. If we say the word non-spontaneous, it does not mean it is impossible. Sodium chloride is not going to dissolve, the salt on your French fries, under ordinary conditions, but you can decompose it electrochemically. And the last thing to keep in mind is spontaneity. It has no time dependence. I took this from a different source, and what it shows is we all know radioactive decay is spontaneous, and it compares technetium with uranium. All right, there's a sample exercise, and I really want you to do these. It says at 1 atmosphere pressure, CO2 sublimes. We have all seen what dry ice done. Actually, we did prior to the pandemic, but now it's kind of hard. Is this process spontaneous at 1 atmosphere? Well, you really need to use the phase diagram. If I pull this phase diagram up from the textbook and I look at 1 atmosphere and I look at minus 100, it is not going to turn into a solid. This is where it is in the gas phase. What else do we have? Well, what are the criteria for spontaneity? Processes that will always occur and they have a definite direction. Think about a rock. It's going to roll downhill. Equilibrium is at the bottom. Think about water. When it's placed in a freezer, it turns to ice, but ice will melt at room temperature. So there's the temperature dependence. If you place a hot metal into cold water, the water is going to heat up. Well, those are things we can quote unquote see. These are two that you will learn a little bit more about in the next chapter. Solid sodium plus chlorine gas will produce solid sodium chloride, and it is a very violent reaction. The one I already spoke about is radioactive decay. All of these are spontaneous. What are non-spontaneous processes? Well, that's if it goes in the reverse direction. What if the rock were to roll by itself uphill? What if steam were to condense into liquid water at 110? What if water was going to decompose into the two gases at room temperature? Non-spontaneous processes. As well as if you walk down the street and burst into flames. People have told me there's a movie about that, but that is a non-spontaneous process. So the other two terms to think about in this section are reversible, and think of that as equilibrium processes, and irreversible processes. If I have a reversible process, this change is made in such a way that you can take it back to its original state by exactly reversing the change. I write in big capital letters, there is no net change. And that describes a melting point or a boiling point. That is a phase equilibrium. That is a reversible process. So if we have 1 mole of water at 1 atmosphere and 0 degrees centigrade, the Q, the delta H, the enthalpy that we calculate, I guess it shouldn't be vaporization, it should be freezing, whether the water is heated or the ice is melted. So these are those phase transition delta H, okay? What's an irreversible process? Well, you simply cannot restore the system to its original state without involving heat and work. The change is going to be on the surroundings. Students tend to have a harder time with this one, so I included the picture that's in your book. If you have a gas in a cylinder, it's right here. If it has a removable partition, it's just been pulled out. The gas will expand into a specific evacuated space when the partition is removed. It will require work to bring it back to its original spot. So again, this is an irreversible process. It could require Q, but it also has to require work. Finally, something new in the 14th edition. Infinitesimal change. If you've taken calculus, you know exactly what I'm talking about. But if not, I'll kind of walk through it. So for a heat flow to be reversible, the temperature difference must be infinitesimally small, and it's really covered in an upper level course. So at the end of your section in your textbook, they say, reversible processes are those that reverse direction whenever an infinitesimal change is made to some property of the system. Think about the boiling point, think about the melting point. Last thing to say, keep in mind, real processes, they can only approximate this infinitesimal change. So all real processes are irreversible. Because spontaneous processes are real processes, spontaneous processes are irreversible. Now, I strongly encourage you to head into the textbook, work question 1912 and 1920 while all of this is fresh in your mind. Please write down whatever questions you have and get some answers.